Okay, good day. For this module, we'll be discussing part 4 of matrix algebra, and we'll be covering the topics of cofactors and adjoint matrix. So another operation that we apply on matrices is what we call your cofactor of a matrix. So the cofactor of a matrix is denoted as the name of the matrix with the subscript cof or simple subscript c. The cofactor of a matrix is simply a numerical grid that is equal to when the column and row of a designated or chosen element is removed in that matrix. The value of the cofactor is always preceded by a negative or a positive sign, which is solved using the equation A sub c of the element ij is equal to negative 1 raised to I plus j times m of the element. So EC here is the cofactor of the chosen or designated element, and we have identified already from our previous discussion that ij is the element number or the location of the element. Mij is what we call the minor matrix or the matrix of minors, which is equivalent to a grid value. So to understand the cofactor of a matrix, given now matrix A with the following elements, so what we will do here is to select an element on our matrix. So let's see, I will choose the element G, which is the element on 3, 1. So we'll be removing the column and the row. So the equivalent matrix now, or cofactor matrix, will be equivalent to the remaining elements, which is B, C, E, and F. So this is our minor matrix, and the value now of your minor matrix is computed as BF minus CE, or that's simply equivalent to the products of the elements diagonally down minus the product of the elements diagonally up. Okay, so you can apply this method and this equation for any square matrix. So to understand further the cofactor of a matrix, let us solve some examples. Find the minor matrix and cofactor of all elements for the given matrix A. So we are given here a 3 by 3 matrix. So what we will do first is to identify the minor matrix of the first element, 1, 1. So what we will do is to first remove row 1 and column 1. So for M1, 1, or the minor matrix of element 1, 1, it will now be 4, 5, 0, and 6. So for the value of the minor matrix or the determinant of the minor matrix, it will simply be 4 times 6 minus 0 times 5. And for the cofactor will now be including our negative 1 raised to I plus j. So with that, we'll now arrive at a positive 24. So next, we move to the second element, 1, 2. So same principle, we remove row 1 and column 2. So the minor matrix now will be 0, 5, and 1, 6. So for A1, 2, we apply the equation negative 1 raised to I plus j times m 1, 1 or M12. So we'll now have negative 1 raised to I1 plus 2J. So multiplied to 0 times 6 minus 5 times 1, giving us a value of A12 equivalent to 5. So we continue with the next element for the problem. So third element is 1, 3. So we remove row 1 and column 3. So the remaining is 0, 4, 1, 0. For the equivalent value of your cofactor for the element 1, 3, that will now be equivalent to negative 1 raised to 1 plus 3 is 4. So multiply that to 0 times 0 minus 1 times 4, or E13 now is equivalent to, that is to negative 4. So next element we will move to on the second row. So we'll have M21. So removing row 2 and column 1. So our minor matrix will now be 2, 3, 0, 6. So applying our equation, that is negative 1 raised to 3 multiplied to 2 times 6 minus 0 times 3. Or the equivalent value now for the cofactor of element 2, 1 is equivalent to negative 12 minus 0, or simply negative 12. So we move to the next element. We have element 2, 2. So remove now row 2 and column 2. So minor matrix for 2, 2 is 1, 3, 1, 6. A22 is equal to negative 1 raised to 4 multiplied to 1 times 6 minus 1 times 3. Or A22 now is equivalent to negative 1 raised to 4 is positive 1 multiplied to 6 minus 3. Or A22 now is equivalent to positive 3. So for our next element, so for element 2, 3, so minor element or minor matrix will be equivalent to 1, 2, 1, 0. So for A23, that is now equivalent to negative 1 raised to 5 multiplied to 1 times 0 minus 1 times 2. Or A23 is equivalent to negative 1 times negative 2, which is equivalent to 2. Okay, for our next element, we have the cofactor and the minor matrix of 3, 1. So we'll have 2, 3, 4, 5. So for the cofactor value, that is -1 raised to 4 multiplied to 2 times 5 minus 4 times 3, that's 12, which is now equal to +1 times -2. So for A31, that is now equal to -2. For the next element, 3, 2. So we'll have our minor matrix 1, 0, 3, 5. So for our equation, that will now be -1 raised to 5 multiplied to 1 times 5 minus 3 times 0, or A32 now is equal to -1 times 5 minus 0 is equal to -5. So for our final element, we have 3, 3. So its minor matrix now will be 1, 2, 0, 4. Okay, and its cofactor value will now be equivalent to -1 raised to 3 plus 3 multiplied to 1 times 4 minus 0 times 2, or A33 now is equivalent to 4. So we have computed already for our minor matrix. We have also computed for the equivalent values of our cofactor for all of the elements. So if we want now to write an equivalent matrix, okay, equivalent cofactor matrix of all our cofactors, so we'll just simply substitute the values of our computed cofactor of the elements in each respective locations. So for A11, we have 24, A12 is 5, -4, and so on. Okay? So if you want to write the equivalent matrix of our minor matrix or your submatrix, this will now be your matrix. So for this matrix, you will just simply apply yung CD, that's CD, BC, EF, HI, yung ating E times I minus H times F. So you will not include the -1 raised to I plus J for the minor matrix or your submatrix. Okay, so if this is our values for the minor matrix or submatrix, or for this is the determinant of the submatrix. So if we're going to solve first for the minor matrix of all the elements, then from here we could also solve your cofactor matrix simply by putting our sign convention. So the sign convention would come from this equation. So this is for your sign convention. And if you're going to notice, -1 raised to a positive value or an odd number is a negative value. So pag add yung sum ng ij, it is negative. Pag even yung sum ng ij, our value is negative. So what will happen now is that for our elements, it will be plus, minus, plus, minus. So, diba ito 1, 1. So, 1 plus 1 is a positive. So, ito 1, 2. So, it's an odd sum. So, it's a negative. This is 1, 3, kaya siya positive. So, ang shortcut natin dyan, ang ating sign convention will be positive, negative, positive, negative, positive, negative, positive, negative, positive. So, alternating lahat ng ating sign conventions. So, ito yung ating shortcut. Okay? So, without memorizing the equation na aij equal to negative 1 I plus j times mij. Okay? So, yung mij natin are these values. And then, negative 1 raised to I plus j are your sign conventions. So, pag-check nyo, same din yung values nito doon sa previous slide natin. Okay? So, another way of writing your cofactor matrix, so ito is the equivalent values of the cofactors. So, if in the problem, it is asked that you write the cofactor of all of the elements in matrix form, then what we will do is to simply write the grid of your minor matrices. So, for A11, ito yan. Okay? So, matrix form yung ating ilalagay. Okay? So, pwede din yung ganitong solution. You write first in matrix form all of the minor matrices of each element, tapos compute nyo na lang. So, 4 times 6 is 24 minus 0, it's 24, and this side is a positive value. Okay? So, let's have another example so that we will understand further, and let's apply the shortcut of the cofactors. Okay? So, let's solve example number 14. So, let's identify the minor matrices and the cofactor of all the elements. Okay, so we have a 2 by 2 matrix. So, please do remember that for a cofactor, this is applicable for square matrices. So, we have 2 by 2, 3 by 3, 4 by 4, and all. So, okay, let's solve problem number 14. So, for our minor matrix, so we'll have m of the first element, which is now 2. So, we'll simply remove the corresponding rows and columns. So, the remaining is 4. Okay. Next element, we have 3. So, that is M12. So, let's remove the corresponding row and column. So, for M12, its minor matrix is 1. Okay. Next, we have our third element, which is M21. Okay. So, remove row 2, column 1. So, its equivalent minor matrix is 3. And lastly, we have our minor matrix of element 2, 2. So, remove row and column 2. So, it is equal to 2. So, this is our minor element. So, if we're going to write now the equivalent matrix of your cofactor, that is now AC, is equal to, so we'll have positive, negative, negative, positive. So we have 4, 1, 3, and 2. So shortcut for a 2 by 2 matrix is that your minor matrix is simply equal to the opposite diagonal of the element. So if we're going to look at it again, so pag yung 2 ang hinanap, minor niya is yung opposite, which is 4. Pag ang hinanap ko is the minor of this element, 1, so ang kanyang minor is the opposite diagonal, which is 3. Okay? So these are your shortcuts. And then again, our sign convention came from negative 1 raised to I plus G. So pag i-check natin, again, for A11, that is equal to negative 1 raised to 1 plus 1, which is a positive 1. Kaya, positive ang sign. So, pag A12, that's negative 1 raised to 1 plus 2. So, it's negative 1 raised to 3. So, negative raised to 3 is negative 1. Kaya siya negative doon. Okay? So, shortcut natin, again, for emphasis is positive ang start. Okay? So, negative, positive, negative, positive, negative, positive, negative, positive. So, kung may fourth row and fourth column ako, continue ko lang. So, this will become negative, positive, negative, negative, positive, negative, positive. Okay? So let's solve problem number 15. Determine the minor matrices and the cofactor for all of the elements for a 4 by 4 matrix J. So same principle as for a 3 by 3 matrix. So for the first element, we have 1, 1. So we remove first the column and the row. So we'll have now J 1, 1 is equal to the matrix 3, 2, 1, 4, 1, 3, 1, 4, 2. So this is our minor matrix. For our cofactor elements, so we'll just be multiplying the elements. So we'll have downwards minus upwards. So we'll have now 3 times 1 times 2 plus 2 times 3 times 1, and then 1 times 4. Okay, so that's minus 1 times 1 times 1 plus 4 times 3 times 3 Then we have 2 times 4 times 2. So if we're going to simplify, we'll now arrive at 6 plus 6 plus 16 minus 1 plus 36 plus 16. So the cofactor value of the first element of matrix G is equal to negative 25. And we have here the positive value or positive sign. So our answer will be this one. So positive times negative 25. Okay, let's move to the next element. So we'll have 1, 2. So we remove again the column and the row. So we'll have for J12, that will now be 421, 213, 341. So again, sign convention natin will be a negative. So same procedure for the equivalent cofactor. We'll have 4 times 1 times 2 plus 2 times 3 times 3 plus 1 times 2 plus 4 minus 3 times 1 times 1 plus 4 times 3 times 4 plus 2 times 2 times 2. And if we simplify this, we'll now have 8 plus 18 plus 8 minus 3 times 48 or plus 48 plus 8. So we'll have a value of negative 25, and we also include the negative sign of the matrix. Okay, so for the next element, 1, 3. So we'll have now this matrix for the submatrix, or what we call the minor matrix. So going down, we'll have 32 plus 27 plus 2, and going up is 12 plus 12 plus 12, which is equal now to positive 25. Again, the positive sign here is simply the sign that we have included for the matrix. Then we have our last column. So we'll have J14. So it's a negative value. Okay, so that will now be equivalent to 64 plus 9 plus 4 minus 24 plus 4 plus 24, giving us a value of negative 25. So we're going to include this now in our matrix. The cofactor of J for the first row will be negative 25, positive 25, positive 25, and negative 25. So let's move to the next row. So row 2. So for the next element, row 2, 1. This will be our minor matrix. So this is the minor matrix. For the cofactor, include the negative sign. And computing for its value, it will now be equivalent to negative 25. And then for next element, we have 2, 2. So this have your cofactor matrix, which is a positive, and computing for the value, that will now be 25. For our next matrix element, 2, 3, which is equal to negative 25. for the next element, we have 2, 4. That will now be equivalent to positive 25. Okay, so putting it now in our cofactor matrix, that will be negative 25, 25, 25, negative 25. So for the next row, have 3. So for the element 3, 1, we have a value of 25. And then for 3, 2, the value is negative 25. For 3, 3, we have negative 25. And for 3, 4, we have negative 25. So let's put this in our cofactor matrix. That will now be equivalent to 25, negative 25, negative 25, 25. Then for our next element, we have 4, 1, which is 25. Then we have 4, 2, negative 25. Next we have this one, 4, 3. So this will be negative 25. And we have 4, 4, which is 25. Okay, so our final equivalent matrix for the cofactor of all elements will now be this matrix. Okay, so that's for cofactor. So the next operation for matrices, we have the adjoint matrix, which is noted by the first 3 letters ADJ of the matrix A. So the adjoint matrix is also called as the adjuvate matrix, or also referred to as the adjunct matrix. So the adjoint matrix is simply computed as the transpose of the cofactor matrix of a given matrix. So by equation, the adjoint now is simply equivalent to the transpose of the cofactor. Okay, so let's have number 16. So determine the adjoint of the problem number 13. So in number 13, we were able to compute for the cofactor matrix. So once you have computed for the cofactor matrix, just get the transpose. We have discussed it already. So the adjoint now will simply be equivalent to the first column. We have 24, negative 12, negative 2. And then we have the second column, which is our second row. That will now be 5, 3, negative 5. And the last column becomes the last row. So that will now be equivalent to negative 4, 2, and 4. Okay, so let's find the adjoint of the given matrix for problem number 17. So we're given matrix R, which is a 3 by 3 matrix. So what we will do first is to determine our cofactor first. So we have 1, 1. So we'll arrive at 24. Okay. And then we have 2, 1, which is 2 times 6, which is 12, minus 0, so that's 12, but the sign convention for our cofactor is negative, so it becomes negative 12. Okay. Next element, we have 3, 1, so that is now equal to negative 2. Next element, we have 1, 2, which will give us a value of 5. So we have 2, 2, which is 3. We have 2, 3, or that is 3, 2, which is equal to negative 5. We have 1, 3, which is equal to negative 4. Then we have 2 or 3. It's 2, 3, which is equal to positive 2. And we have 3, 3, which is equal to positive 4. So for our cofactor matrix, that will now be, so positive 24, positive 5, negative 4, negative 12, negative 3, positive 2, negative 2, negative 5, and positive 4. So for our adjoint or the adjugate, you just transpose the cofactor matrix. So we'll now have negative 24, negative 12, negative 2. Column now becomes the row, positive 3, positive 5, positive 3, negative 5. Column becomes a row, so we'll have negative 4, positive 2, and positive 4. Okay, so before we end our discussion for cofactor and adjoints, again, we have a review. So for cofactors, again, given a matrix, that will simply be equivalent to the matrix when we remove your column and your row. Okay, so once we have identified your minor matrix, we compute for the equivalent value, which is equivalent to the sum of the products of elements moving down minus the elements or the products of the elements moving up. So if you have computed for all the values of each elements for the cofactor, you transfer it to your cofactor matrix, equivalent cofactor matrix, with the following sign conventions. So we have positive, negative, positive. So it's an alternating sign convention for each element. Okay, so for the adjoint, once you have taken the cofactor of all of the elements, you just simply compute for the transpose of that matrix.